In this video, we're going to be looking at topic 1F, Ionic Bonding, and we'll be focusing on these single science outcomes as part of the IGCSE chemistry course from Edexcel. So as part of the single science course, you need to know how ions are formed, you need to know the charges of specific ions, be able to write the formula for compounds made up of these specific ions, understand ionic bonding in terms of electrostatic attractions, and then understand why they have high melting and boiling points. So what do we mean when we're discussing ionic bonding? Well, an ionic compound is formed when we get electrons being transferred between metals and non-metals. So an ionic substance will always contain at least one metal and one non-metal. And it is the electrostatic attraction between positive ions that are formed and negative ions. And all types of bonding will all be a form of electrostatic attraction. And this just means that we have a positive and a negative being attracted to each other. Now, what changes for each of the different types of bonding is what those particles are. And for ionic bonding, it's the positive and negative ions. So we need to know how we actually form these positive and negative ions. And it is all to do with when they lose or gain an electron. So you should know the electronic configuration for the first 20 elements. You will have looked at that in topic 1C and 1D when you looked at how electrons are arranged. Now, of these first 20 elements, they all want to have the same electronic configuration as a noble gas, meaning they have full stable shells. So our first shell, we want it to have 2. Our second shell, we want it to have 8. And our third shell, we want it to have 8. That would be a stable outer shell. So in order to do this, they will either lose electrons or they will gain electrons, and what this does is it causes them to be an imbalance of either positive charges or negative charges. So in an atom, they are neutral because our protons equal our electrons. In ions, they can either be positive, where our protons is higher than our number of electrons, or they can be negative, where our number of protons is less than our number of electrons. So if a substance loses electrons, it becomes positive, and if it gains electrons, it becomes negative. And if we have substances that have the same electronic configuration, we say that these are isoelectronic. Let's look at how these ions are actually formed. So if we want to make a compound of sodium chloride, we've got the Na, which is sodium, with an electronic configuration of 281, and we have chlorine or chloride in the compound, which is 287. Now, each of these want to get to a noble gas formation. And the noble gas that they want to be like is argon, which has 288. Full outer shell, or they may want to be like neon, which is 28. So in order to do this, what happens is this outer electron here from the sodium is actually transferred to the chlorine. So we get this transfer of electrons. And when this happens, we form ions. So we form a sodium ion, which now has the electronic configuration 28, and a chloride ion, which is 288. So this red electron from the sodium has transferred over to the chlorine. And we can see that there is a difference in our number of protons and electrons. So our protons don't change for sodium, they stay as 11, the same as they are for an atom, but in the atom we have got 11 electrons. So these ones are our atoms, and these are are ions. So we have 11 electrons in the atom, but when we look at the ion, you can see that we only have 10 electrons. So this becomes positively charged by one extra charge. So it becomes a 1 positive ion. For chlorine, its number of protons is 17, and that does not change for the ion. I haven't moved anything to do with the protons. But in the atom, I have 17 electrons, whereas in the ion, I have 18 electrons. So I have an extra negative charge, meaning that becomes a charge of 1 negative. So that transfer of electrons gives you your ions. And this happens because the non-metal element is going to have a stronger attraction for the electron than the metal element. So the non-metal is going to take the outer electron away from a metal and transfer it into the outer shell of the non-metal. So metals will lose electrons and they will become positive ions, which are also known as cations. And non-metals will gain electrons and they will become negative ions, which are also known as anions. And you'll be able to see a pattern in how this happens. So group 1 has 1 outer electron, so it can lose 1 electron. And when it does, they will form a 1 positive ion. Group 2 has 2 outer electrons, so it will lose 2 and become a 2 positive ion. Group 3 is still metals and it will lose 3 electrons and become a 3 positive ion. Now group 4 tend not to make ionic substances. So they tend not to make ions. So we kind of skip over group 4 and then we go to group 5. Now once we get to group 5, these are our non-metals. So groups 1, 2 and 3 are our metals, whereas 5, 6 and 7 are our non-metals. And our non-metals are going to gain. And if it's group 5, it wants to get up to a total of 8, so it will gain 3 electrons, making that a 3 negative charge. Group 6 will gain 2, making it a 2 negative, and group 7 will gain 1, making it a 1 negative. So you can see that we have a pattern of forming 1 plus, 2 plus, 3 plus, and then 3 minus, 2 minus, 1 minus. It is very important for you to be able to identify those so that you can determine the ion that will be formed based on where the element is positioned in the periodic table. So I would strongly recommend that you memorize this table. Now for ions of elements that are above atomic number 20, so remember atomic number 20 is calcium, so for other ions, there sometimes may be issues with you figuring out their charge because you don't actually have to know their electronic arrangement. The electronic configuration for GCSE is only up to 20. So for some substances like iron or copper or silver, you are not told those. You don't need to know those, you will be told them. And these again are the key ones that you have to know, and I would strongly suggest that you memorize them. So we have our positive substances, or our cations, and we have silver, positive, hydrogen, positive, and ammonium, which is a complex ion, which is NH4, is also 1 positive. So a complex ion is 1 or more elements. So rather than just looking at one individual element as an atom, a complex ion has a group of elements. Now we also have some negative substances, which is our nitrate is NO3 1-, hydroxide OH-, carbonate CO3 2-, and sulfate SO4 2-. Those are things that you have to know. So again, make sure you memorize these. The other thing that you could sometimes see if it is a particular metal is you may see the use of Roman numerals. And this is discussed further in topic 1E in the calculations. But you may see something like copper 1, which means it has a 1 plus charge, or you could see copper 2, which means it has a 2 plus charge. Anything with Roman numerals for GCSE will be a metal, and you just need to know the Roman numerals to determine how many positive it is. Moving on, we're going to look at how ionic substances are actually joined together. And what we need to understand is for ionic substances, there is not a fixed number of atoms. Ionic substances can actually contain hundreds or thousands of ions in a specific shape, and we call this structure a lattice. And you can see it looks something like this. It's a giant 3D structure where you get a regular repeating pattern of positive, negative, positive, negative. So our green here are our negative chlorides, and the purple are the positive sodiums because they are that little bit smaller. And these join together and they form this lattice structure. And notice that we have a specific number in this diagram. However, we could also have a different diagram of sodium chloride that has different numbers. So just keep in mind that it is not a fixed number. Any formula that we use for an ionic substance tells us the ratio of our two ions, and we'll look at that in a little bit more detail in just a minute. But this regular repeating pattern of positive, negative is called an ionic lattice structure, and these lattice structures can be giant. So they are not small individual molecules, they are large lattice structures. Now, when we look at sodium chloride, or NaCl, which you may know as table salt, each sodium ion is surrounded by 6 chloride ions, and then each chloride ion is surrounded by 6 sodium ions. So we get that constant being surrounded by an ion of a different charge. So we have that positive ion surrounded by 6 negatives, the negative ion surrounded by 6 positives. What this means is we have equal numbers of the sodium and the chloride ions in our lattice. So we look at the ratio of Na to Cl, and it is 1 to 1, so we write the formula as NaCl. If we had a ratio of 1 to 2, for example, for calcium and chlorine, they're in a 1 to 2 ratio, your formula would be CaCl2. So you always have to look at the ratio between the different types of ions to determine what its formula would be. Now, because our ionic lattices do contain this huge number of positives and negatives, we are looking at, as we said, the ratio rather than the actual number of ions. And what's important is that in an ionic formula, your charges must balance out. So the overall compound must be neutral. So you have to have a balance of your positives and your negative ions when you're writing out these formulas. Let's look at some examples of how we figure out an ionic formula. So first of all, we want to look at sodium fluoride. So we know that sodium is in group 1, so it's going to make that 1 positive ion, which is Na positive, and fluorine is in group 7, so it is going to make the 1 negative fluoride ion. So now we balance out our charges. So we have +1 and -1. They're already balanced, so we don't have to do anything, and our ionic formula is Na plus F minus. Notice for an ionic formula, we always show the charges. So we have to make sure that we show the different charges. If it is just a chemical formula, then we don't have to show the charge. But if we're asked for an ionic formula, we do. Another example is potassium oxide. So potassium is in group 1, so it makes a K plus ion, a 1 positive. Oxygen is in group 6, so it's going to make a 2 minus ion. So when I look at my charges, I have 1 plus and 2 minus. Now these two things do not cancel out. So what we have to do is we have to add in an extra potassium to give us 2 positive charges and 2 negative charges from the oxygen. Now these are balanced, I count out what I have. So I have K plus, and I have 2 of them, and I have O, 2 minus. That is my ionic formula. So I show the charge and I show a subscript to show how many of them I have. If we look at aluminium oxide, aluminium is going to make a 3 positive ion, and oxygen, we've already said, makes a 2 minus. So when I look at my charges, I have 3 positive and 2 minus. You can see that they are not balanced. So if we add in an extra aluminium, we end up with 6 positive charges. What do I have to do to the oxygen? Well, if I add in 1 more, that gives me 4 minus, but that's still not enough. So I need to add in a third to give me 6 minus. Now I have 6 positives and 6 negatives, so they are balanced out. So I'm going to write my ion, Al3 plus, and how many do I have? I have 2. I have oxygen 2 minus, and I count 1, 2, 3, so my subscript is 3. And that is the ionic equation for aluminium oxide. And lastly, we have iron 3 sulfate. So this is one that uses Roman numerals and a complex ion. So the iron 3, that 3 of the Roman numerals tells us it makes a 3 plus ion. And sulfate is one of the ones that you have to memorize. It's SO4 2 minus. So again, I look at my charges. I have 3 plus and 2 minus. These are not balanced, but you can see it's similar to our aluminium oxide. So I'm going to add in an extra Fe3 plus, and that changes my positive charges to 6. 1 more SO4 will change my negatives to 4 negative, but I need 6, so I add a third one, and that gives me 6 negative charges to balance out our 6 positive charges. So to write my ionic equation, I write each ion, Fe3 plus, and I have 2 of them, and then I have SO4 2 minus, and I have 3 of them. So that is my ionic formula for iron 3 sulfate. You might want to try practicing writing out ionic formula for different compounds. If you ask your teacher, they should be able to give you some examples. Now we want to look at the properties of ionic substances, and there are a couple of key properties that you have to know and be able to explain. The first one is melting and boiling point. Now, our ionic substances have very strong electrostatic forces between the ions, meaning it has a very strong attraction between the positive and the negative ions. That's what we mean by electrostatic forces or electrostatic attraction. Our positive ions are strongly attracted to our negative ions. And in order to overcome this very, very strong attraction, we need a very high energy. So we need to put in lots of energy to break this attraction. And this causes high melting and high boiling points for ionic substances. Whenever you need a high energy to break the strong bonds, you need a high melting or boiling point because you need to put in more and more energy. So this is a key property that you have to know, and you have to be able to say it's due to the fact that they have these strong forces that need lots of energy to be broken. Ionic compounds also tend to be crystalline in nature, so they form crystals, and this is due to this regular arrangement of ions in the lattice. So this lattice structure gives you crystals, and you've probably seen this when you've seen NaCl. When you look at salt, especially if you look under a microscope, you can see its structure is like that of a crystal, and it is because of this lattice. Now, some of the crystals are so small that they look just like a really fine powder, and an example would be magnesium oxide. It is made up of crystals, but they are so small it just looks like a powder, and you would potentially have to look at it under a microscope. You also need to know a little bit about durability, where our ionic compounds tend to be brittle. And another word for brittle is just being easily broken. And why is that the case? Well, again, it's due to this lattice structure. So when you have this lattice, if you apply a force to your structure and that causes part of your lattice to shift, what then happens is you get two negative charges lining up, two positive charges lining up, and so on and so on. So rather there being an attraction, like there would be in the lattice as normal, we get a level of repulsion because two like charges don't like to be next to each other. So as soon as these like charges come into contact after being moved due to this force, then they're going to repel each other, meaning we can easily break apart the ion lattice because these ions don't want to be close together. So ionic compounds do tend to be brittle. Let's now finish off by looking at some past paper questions to apply what we've learned in this process. So the electronic configuration of a sodium atom is 281. Sodium oxide, which is Na2O, is an ionic compound formed when sodium reacts with oxygen. We want to describe, in terms of electrons, very important, what happens when sodium oxide is formed in this reaction. And this is a 3-mark question. So the first thing we need to understand is that, of course, this is an ionic compound. So ionic substances are made by transferring electrons. And we are transferring the electrons from the sodium to the oxygen. So one sodium atom transfers an electron to oxygen. So then that one sodium is going to be happy because it has an outer shell, but oxygen is still one left. So actually what happens is then a second sodium then does the same. So we've got two sodium atoms, each transferring one of their outer electrons to that oxygen atom to make that into an oxygen ion. So we have our sodium atom going from 281 to a sodium ion, which is 28, and this happens twice. And we have our oxygen atom, which is 26, forming oxide ions, which would be 28, because it gains one electron from each of the two sodiums. For this question, we want to complete the table to show the arrangement of the electrons in ions when potassium and sulfur react to form potassium sulfide and then give the charge on each of them. Well, potassium is going to lose this one outer electron, so its arrangement will become 288. And if it only loses one electron, it's in group 1, and we know that the charge becomes 1+. For sulfur, it has 6 outer electrons, so it's in group number 6. Well, we know it's going to want to gain 2 electrons to make it 288, and that will become a 2 negative ion, because we have group 1, which forms 1 positive, and group 6, which forms 2 negative. You learned that back in the table previously in this video, so do make sure that you have that memorized because you can be asked about it. And then for part B, explain why potassium sulfide has a high melting point. Well, that's what we were just talking about in terms of the electrostatic attractions. So there are strong electrostatic attractions, and it's very important that you always use this term in your answers whenever you're asked about bonding. So strong electrostatic attractions between the oppositely charged ions. So we have to specify that it is between the positive and the negative ions. So you could either say oppositely charged or positive and negative, which require a large amount of energy to be broken. So because we require that large amount of energy, it gives us a very high melting point. So you would get 1 mark for mentioning the electrostatic attractions between the ions, 1 mark for saying they are very strong, and then the 3rd mark for saying it requires a large amount of energy in order to break. And there is the mark scheme for those questions if you have been trying them yourself. I would strongly suggest that you do practice your Ionic formula and make sure you understand each of the different points with regards to how to answer the questions on bonding and how to answer the questions linking bonding to properties. If you do have any questions, please feel free to leave a comment below, and we hope to see you back on the channel.